purpose of this lab is to do 3 reactions and compute the delta H, the enthalpy of the reaction. This first reaction is a strong base with a strong acid. That's called a neutralization reaction. So sodium hydroxide and HCl. So we're going to mix 20 mils of 2 molar sodium hydroxide, and we will mix that with 20 mils of 2 molar HCl. Once again, strong acid, strong base. And we will get sodium chloride, which is dissolved in water, and liquid water. So we will figure out the delta H, measure the heat that's given off during this reaction. The second enthalpy of the reaction that you guys will calculate is taking ammonia, NH3. This is a weak base with the strong acid HCl. And this is the product that we will get, ammonium chloride. So same situation, 20 mils of 2 molar concentration. And then our third reaction that you have to compute the delta H for is sodium hydroxide. Now this is a strong base with ammonium chloride, and that's going to give you sodium chloride and ammonia. Again, we're going to take 20 mils of a concentration is 2 molar and mix it with 20 mils whose concentration is 2 molar. So if everything is a volume of 20 mils and everything is a concentration of 2 molar, how many moles are you adding in each of these reactions? How many moles are you mixing together? So for that, it's a very simple calculation that you can fill out in your lab handout. So all of these we're going to mix 20 mils, so 20 mils of each reactant. So 20 mils, all of these bottles are going to be 2 molar. What's shown here is a concentration of 2 molar sodium hydroxide. So we're going to take 20 mils, convert it to liters, so the mils and mils cancel. And 2 molar, big M is moles per liter, so the liters cancel. So all of these will be 0.04 moles. So that is how much you're mixing. You're mixing 0.04 moles together for a total volume of about 40 mils. So let's go ahead and do this reaction and collect our data. So we weighed out our calorimeter here. Okay, this is just 2 cups. That will serve as our calorimeter. Let's put this inside this container. And here's the container's lid. So right now for our first reaction, which is sodium hydroxide and HCl, let's pour the NaOH in here. Okay, so pouring the sodium hydroxide. We got our little lid. All right, so here's our temperature probe. All right, so this will measure our temperature on our computer screen. So if we go to our screen here, right, so with nothing added, just the NaOH, we will hit collect and sort of let it do a little baseline. So this is a baseline of the temperature of the NaOH alone. About 45 seconds or so, we will add our HCl, and then a reaction should happen. When we add our HCl, either the temperature will go up or the temperature will go down. All right, so now let's add our HCl. You want to do this kind of quickly as possible. Okay, I poured the HCl in, and we're going to do a little bit of stirring. Okay, so make sure it stirs. And then automatically, as you see in the computer screen, the temperature has sort of risen up. Okay, and now the reaction has occurred. You notice the temperature has risen and it's stabilizing. So we're going to let this stabilize till it reaches about maybe 100 to 150 seconds. Kind of want it to just sort of flatline. And I'm just gently stirring. Okay. All right, so the temperature is kind of flatlined or baseline. This is the point here where I added the HCl to the cups that already contain NaOH. So we want to click stop our data collection. And now we will figure out the minimum temperature and the maximum temperature that this reaction underwent. So this is sodium hydroxide and HCl. So we're going to click, left click, and sort of collect everything. And then here there is a button called Stat. We can click on that, or we can go to Analyze and statistics, so either one is fine. And we will capture and note down our minimum temperature and our maximum temperature. So our minimum temperature was 20.16 degrees C. Our maximum temperature was 33.91 degrees C. So that's something we need to note down in order to figure out our delta H for this reaction. So our reaction is complete, so let's weigh out our solution here. This contains inside the cup sodium hydroxide and hydrochloric acid. This is reaction 1. And the mass of the solution here is 47.23 grams. So remembering our concentrations for all of these reactions in the bottle is 2 moles per liter. We take 20 mils and react with each of these, so that's about 0.04 moles. We calculated the mass of the 2 styrofoam cups by themselves, which was 4.46 grams. We didn't add the magnetic stir bar because I just stirred it using the temperature probe. So here's our data for our first round. The mass of the solution, remember this contains HCl and NaOH, was 47.23 grams. Okay, 47.23 grams minus the 4.46 grams gives us the mass of the solution alone, 42.77 grams. Our maximum temperature was 33.91 degrees C. Our minimum temperature was 20.16 degrees C. Our change in temperature is final minus initial. So remember the temperature rose, so it's going to be 33.91 degrees C minus 20.16 degrees. Our change in temperature after we added HCl to the NaOH, the temperature rose, and it rose by 13.75 degrees C. That's our change in temperature. Let's go ahead and calculate the rest of this later. All right, so let's do our second reaction. This is going to be NH3 with HCl. So here's my NH3 ammonia. I'm going to pour it in here. Let's collect some baseline data. Put the cap on. Put our temperature probe in. And let's hit collect. We'll let that go for about 45 to 50 seconds. So we captured some baseline data. It's been about 45 to 50 seconds, so let's quickly pour in our HCl. Let's pour it in. And then do a little bit of shaking also. So while it's collecting the data, you want to shake this, keep it stirring. And let's see what happens. Our temperature, just like in our first reaction, has risen. So let that stabilize. Maybe I'd say let it go to about 100 to 125 seconds before you click the red stop and get the minimum and maximum temperature. Our minimum temperature and our maximum temperature. Notice when we added HCl to NH3, just as before, the temperature rose up. So we're going to highlight this with our mouse all the way here. So we can also click on Stat, okay, that button there, and it should give us the same thing. So here, our minimum temperature was 20.16. Our maximum temperature is 30.53 degrees C. Let's note that down in our results section. All right, so the mass of the solution in the calorimeter cup was 44.24 grams. Okay, we're going to subtract that from the mass of the cups alone, which was 4.46 grams. And so doing that subtraction, we get the mass of our solution is 39.78 grams. Our final temperature when we mixed HCl with NH3 was 30.53 degrees C. Our initial temperature was 20.16 degrees C. Change in temperature final minus initial is 10.37 degrees C. And we will figure out how to compute these later on in the lecture. All right, here we go with our third and final reaction. This is going to be sodium hydroxide with ammonium chloride, NH4Cl. So here our NH4Cl is going to be inside our cups, our calorimeters. All right, so we poured it in. And let's collect some baseline data, about 40 to 45 seconds. All right. right, so now let's add our sodium hydroxide. So you want to do this kind of fast. And also don't forget to stir. So the temperature is rising up in our third reaction, but not as much as the first two reactions, is it not? So we're going to let this flatline and go to baseline. All right, so here is what our third reaction profile looks like. Let's kind of zoom in on this, so make the graph look more pleasing. So instead of having the y-axis maximum be 40, let's have it at 25. And instead of this being minimum at 615, let's have it maybe at 20. So basically we're just zooming in. All right, so you can see the graph looks a little bit better when it's zoomed in like that. Let's do the same thing as before. We're going to capture our minimum and maximum temperature. We'll highlight it with our mouse. And then we're going to click Stat here. It's a little bit easier. Click Stat. Here, the minimum temperature was 20.42 degrees, and our maximum temperature is 21.67 degrees. So the temperature didn't really go up that much. Let's note down these values, and also let's get our weight of the solution. All right, for our third reaction, ammonium chloride and sodium hydroxide, the mass of our solution was 46.38 grams. We just weighed the coffee cups with the solution inside. So that's the mass of the solution with the cups. So subtracting that from the mass of the cups alone, which was 4.46 grams, we got a final mass of the solution inside to be 41.92 grams. Our change in temperature, so this reaction, the temperature went up, but it only went up slightly. The maximum temperature was 21.67 degrees. The minimum temperature was 20.42 degrees. Change in temperature, final minus initial. Our final temperature was 21.67. Our initial was 20.42 when we started, before the addition of the NaOH. And so our difference, our change in temperature is 1.25 degrees. So let's figure out the delta H for this reaction. Our first reaction with strong base NaOH and strong acid HCl. The delta T that we computed, final minus initial, was 13.75 degrees C. So we're interested in the heat of the system. So to do that, we must calculate the heat of the solution, and that's going to be Ms delta T. So the mass for reaction 1, according to our data table, was 42.77 grams. S is the specific heat. We'll use the specific heat of water. That's a constant that's in our lab handout. So that's 4.184 joules over grams degrees C, times our delta T, which is our change in temperature, which is from our results is 13.75 degrees C. So the grams cancel, degrees C cancel, and we're left on our calculator computing it to be about 2461 joules. We also have to figure out the heat of the calorimeter. So when we did this reaction and added NaOH and HCl together, this also took in some of the heat. So we're going to call that heat that's taken up by the calorimeter Qcal. So that's going to equal to the heat capacity of the calorimeter, okay, how much heat these cups absorb, times the change in temperature. So the heat capacity of the calorimeter from our book, the lab handout, was 10 joules over degrees C. That's the constant. Our delta T is 13.75 degrees C. That's what we calculated. So the degrees C cancel. This is about 137.5 joules. So the Q of the system, according to the protocol in your lab handout, is going to be the minus of this addition, Q solution plus Q cal. So we have Q solution here, 2461 joules. We have Q cal here, 137.5 joules. This is the heat taken up by the solution when we mix them. This is the heat taken up by the calorimeter when we mix them. We're going to take the minus of that, and we will get an answer minus 2598 joules. Now what we need to do now is take that 2598 joules and do it in joules per mole. Now the thing is, we added equal number of moles, so it doesn't matter if we do per moles of NaOH or per moles of HCl, because all of it was 0.04 moles. So we're going to take that minus 2598 joules and divide it by 0.04 moles, 64,950 joules per mole. And let's convert that to kilojoules per mole. That's our customary unit. So 1, 2, 3 is about minus 65, rounding, kilojoules per mole. So we only did this one time. If you do the more thorough lab, the more complete lab, we actually do this twice and take an average. But for now, this first reaction has a delta H of minus 65 kilojoules per mole. Acid HCl, our change in temperature was 10.37 degrees. Following along what we did with reaction 1, Q of the solution is Ns delta T. So the mass of our solution here, after we weighed by difference, is 44.24 grams. This S is the specific heat for water, so it's a constant from your lab handout. And our change in temperature is 10.37 degrees. So doing all of that math, we get an answer of 1919 joules. Cannot forget the heat that's also taken in by the calorimeter. So that's QCal. QCal is C, heat capacity times delta T. And just as before, reaction 1, that constant is 10. Our delta T is 10.37. And we get a value of 103.7 joules. And don't forget the cancellation of our units. Degree C cancels, giving us joules. Grams, degree C cancel, giving us joules here. Finally, according to the lab handout, Q system is minus the sum of Q solution and Q cal. And our correct answer here, when we compute that, is minus 2,023 joules. So this is the answer we got from our data in our hands. And it's joules, but we want to do it in joules per mole. There's 0.04 moles that we mixed. So it's about minus 50.6 kilojoules per mole. That will be our delta H for reaction 2. Small increase in temperature. So going through the exact same procedure as before. Okay, our mass, our specific heat. Remember, this is the specific heat that was given to us in our lab handout. Our delta T is 1.25. Going through that is 219 joules. QCal, which is the heat absorbed by the calorimeter apparatus. The heat capacity is 10. Our delta T is 1.25. Our heat absorbed by the calorimeter is 12.5 degrees C. Q system is going to be minus the sum of QCal and Q solution. Now, I've got to tell you that all of this is in our lab handout, so no real need to derive any of this. And we get an answer of minus 231.5 joules. We want it in joules per mole, and I even went ahead further and converted it to kilojoules per mole. So our final delta H, doing one trial, is minus 5.79 kilojoules per mole. That is our computed enthalpy. One point I want to mention to you guys is notice the minus signs. Notice the minus signs, and notice, if you remember the graph, the temperature actually went up. The minus signs and the temperature going up after we mix the two together indicates that this, and all these three, in fact, are exothermic reactions. One of the questions in your post-lab for this experiment asks you to determine the enthalpy for this reaction. So this is a good application of Hess's law. So if you notice here, we have NaOH, and we have NaOH here. That's on the reactant side. We have NH4Cl, and then we have NH4Cl, but this one here that we just computed is on the product side, and here's on the reactant side. Here we have NaCl product, we have H2O liquid, both on the product side, and then we have NH3 aqueous on the product side, and NH NH3 aqueous on this reaction that we just calculated on the reactant side. So just looking at these two reactions and looking at this reaction, one thing that you notice, okay, I'm going to rewrite this reaction and I'm going to flip this reaction. Remember one of the rules, we flip a reaction, we change the sign at the end of it. So let's rewrite this reaction here, reaction 1, of which we computed the enthalpy to be minus 5 kilojoules per mole. I'm going to take the second reaction here and I'm going to flip it. Okay, so now the NH4Cl is on the reactant side, which is what I want. So NH4Cl, so let's put this in blue. We computed that to be about minus 50.6 kilojoules per mole, but we flipped it. So flipping the reactants become products, products become reactants. So we flip the reaction, we flip the sign. Something nice happens when we add these two reactions together. What happens is that this HCl cancels out with this HCl, and we are left with NaOH plus NH4Cl. AOH is dissolved in water, plus NH4Cl aqueous gives us NH3, NaCl plus water. All right, so we got our net reaction, so this reaction and this reaction. So the delta H here is simply the addition of this, so minus 65 plus 50.6. So doing that on my calculator, I'm getting a delta H for this reaction of about minus 14.4 kilojoules per mole. What we calculated here was about minus 5.79 kilojoules per mole. A little bit of a discrepancy, so one of the questions in the post lab is to explain some of the possibilities with regards to this discrepancy in terms of Hess's law versus what we actually calculated when we did it in the lab.